In the last video, we showed you how we can test the performance of an already trained network. In this video, we're going to show you how to train a network from scratch using supervised action information and supervised GPS input. You can also supervise the attention of the network and the type of the objects required to be recognized. In this demonstration, we're only going to supervise the action concept zone and the GPS signal input. Here you see me starting the application. Go to Settings, select Real-Time Training Mode, and then select Create Network. On this screen, you see some of the parameters to create the network. We do not change those parameters in this demonstration. Press Create Network. Make sure that we are in training mode. Go back to Main Activity. Connect the controller. Now that the controller is connected, we supervise the current GPS signal to forward and the current action to forward. Press Start and the network is being trained with the supervised action, the current input image, and the simulated GPS signal. The update speed of the network is about 0.21 to 0.24 seconds per frame. Here we change the current GPS input to right and the action of the network to right. Here we change the current GPS input to left and the correct action of the network to left. Here we change the current GPS input to forward and the correct action of the network to forward. Here we change the current GPS input to left and the correct action of the network to left. Here we change the current GPS input to right and the action of the network to right. The network is required to be able to recover from the wrong phasing direction. Thus, we need to train the network to turn slightly right when the user overturns to the left-hand side. Similarly, the network needs to turn slightly left when the user is turning too much to the right-hand side. And finally, when the GPS tells that we have arrived at our destination, the network should generate an output of stop. Okay, so now that we have trained a new network for 3 minutes with different actions, let's test the performance of our newly created network. The plan is to head back to our starting point. The environment looks similar to our training images, but not exactly the same. The network needs to transfer what we learned in the previous training session to this environment and lead us back to where we started. I switched the mode to real-time testing mode. Change the GPS signal to forward. This time, we do not supervise the action of the network. Instead, we will follow the network's output at the upper region of the screen. Due to reflections and glares from the sun, we map the output action to the right-hand side of this video. As you can see, the network learns to follow the road with satisfactory performance. When I am facing the wrong direction, the network reminds me to turn slightly right or slightly left to face forward. Here, the GPS signal is changed to left, and the network follows the GPS signal and asks me to turn left. When the GPS signal changes to turn right, the network asks me to turn right. Remember that the network is now trained on these settings. When we passed these intersections 3 minutes ago, we were performing different actions facing the other direction, and we only trained the network for only once. Thus, it is really impressive that the network can learn to behave correctly in such short time. Here, I deliberately overturned to the left-hand side, and I'm currently about to walk off of the sidewalk. The network has never been trained to adjust direction to avoid this situation when the user is turning left, thus this error is expected. This error can be removed by more intensive training. So as you can see, the network already learned to correct my direction and follows the GPS input with only 3 minutes of training. Now I change the GPS input signal to arrive, the network tells me to stop, and we're back at our starting point. The network we used in the other demonstration had been trained with 4 hours of navigation data at different times and places around the campus. For more information, please check out the real-time testing demonstration posted by our lab.